Out in the cold waters of the North Sea, 45 kilometers from Belgium's coast, a giant construction is underway. It isn't a city, a port, or a fortress. It's something new, an artificial island designed to capture the power of the wind and feed it to an entire continent. This is Princess Elisabeth Energy Island. The origins of an energy revolution. The story of Princess Elisabeth Island starts years before the first concrete structure was lowered into the sea. Belgium, a country with a relatively short coastline, has always depended heavily on imported fossil fuels. But in recent decades, it transformed into one of the world leaders in offshore wind energy. Today, Belgium already ranks 7th globally in installed offshore wind capacity. Back in 2016, Belgium and 8 other North Sea nations agreed to develop a North Sea Wind Power Hub, a collaborative plan to connect offshore turbines into a shared electricity grid. The vision was bold. When one nation had surplus wind power, it could sell or transfer that energy instantly to its neighbors. Even landlocked Luxembourg signed on, despite not having a coastline, committing to buy renewable energy from the sea. But the real push came later. In 2022, Russia's invasion of Ukraine drastically reduced Europe's supply of natural gas. Suddenly, offshore wind was no longer just a climate policy. It was a matter of energy independence. By the 2023 North Sea Summit in Ostend, leaders of 9 countries, alongside European Commission President Ursula von der Leyen, pledged to quadruple offshore wind power by 2030 and to increase it tenfold by 2050. That meant building thousands of new turbines and, just as importantly, creating offshore hubs to gather and transmit the electricity. Belgium, with no natural islands, chose to build its own. The Princess Elisabeth Zone. The chosen site sits in the Princess Elisabeth Zone, southwest of Belgium's existing offshore wind farms. This zone will soon hold hundreds of turbines, collectively generating 3.5 gigawatts of power, enough to supply millions of households. In the center of this zone will rise Princess Elisabeth Island, the world's first artificial energy island, designed as both a collector and a gateway. Instead of laying separate cables from each wind farm to the mainland, the island bundles everything together. The electricity is gathered, transformed, and then transmitted through a single powerful connection to Belgium. That makes the system more efficient, cheaper to maintain, and easier to scale. But the island isn't just a Belgian project. It is intended to serve as the heart of a future international grid. 2 massive subsea cables are already planned: Nautilus, which will link the island with the United Kingdom, and Triton Link, which will connect it to Denmark. Together, they mark the start of a transnational network designed to one day generate 300 gigawatts of power, enough, Belgium claims, to supply 300 million homes, more than all the households in Europe combined. Building the world's first energy island. To create something this ambitious, engineers had to start with the basics, a structure that could withstand the brutal conditions of the North Sea. Belgium's coastline has no natural islands, so everything had to be built from scratch. The foundation of Princess Elisabeth Island is formed by 23 enormous concrete caissons. Each caisson is around 58 meters long, 32 meters high, and weighs up to 22,000 tons. They are being built on land at Vlissingen in the Netherlands, at a special fabrication yard in North Sea Port. The construction technique is known as slip forming. It involves pouring concrete continuously 24 hours a day, 7 days a week, so that the structure grows upwards at a steady pace of 8 to 10 centimeters per hour. Each caisson takes about 3 months to complete, with a workforce of around 800 people. For this project, the joint venture TM Edison partnership between Jean Denul and Demi requested that the caissons be built with Ecoplanet low-carbon cement, developed by Holcim, Belgium. This cement is sulfate-resistant, strong enough to handle the chemical conditions of the North Sea, and durable for at least 100 years. Most importantly, it reduces carbon emissions by more than 40% compared to traditional cement. Once finished, each caisson is floated out by tugboats to the offshore site, carefully positioned and then filled with water, sand, and rubble so it sinks securely to the seabed. When all 23 are in place, they form the perimeter ring of the island. Inside that ring, dredgers will fill the space with 3 million cubic meters of sand, compacted using a method called vibroflotation. This technique involves driving a probe into the sand, injecting water, and vibrating the grains until they settle into a dense, stable mass. On top of this, engineers will lay rock revetments, about 82,000 cubic meters of stone, to protect the harbor and the shoreline of the island. By the time it is finished, Princess Elisabeth Island will cover 6 hectares, roughly the size of 8 football pitches. It will include a small harbor, a helipad, and docking facilities for crew transfer vessels. Inside the energy hub, the true purpose of the island, though, is not the sand or concrete. It is the electrical infrastructure that will sit on top. The substations being installed will be capable of handling both alternating current and direct current. AC is what powers most homes and businesses and is efficient for shorter distances. But for long distances, particularly undersea transmission to other countries, DC is much more efficient, with far less energy lost along the way. That dual system is what makes Princess Elisabeth Island unique. It will not just send power back to Belgium. It will also prepare electricity to be exported to Britain and Denmark, and eventually to other countries as the network grows. The construction timeline reflects the complexity of the task. Work began in 2022, with caisson building starting in early 2024. The concrete works are expected to continue until mid-2026. The island itself should be structurally complete by 2028, though the full energy infrastructure may not be online until 2030 or beyond. The financial challenge. The engineering feats are impressive, but they come at a steep price. When the project was first estimated in 2021, the cost was around $2.7 billion. By the latest count, it has soared past $8 billion. Part of the increase can be explained by global inflation and higher costs for raw materials. But the largest factor is the supply squeeze in high-voltage direct current equipment. Only a handful of companies worldwide manufacture the specialized converters and substations needed for projects like this. With so many countries launching offshore wind initiatives at the same time, demand has skyrocketed. As prices rose, buyers grew wary. In January 2025, a group of European energy consumers called for the project to pause and be redesigned. A few months later, in June 2025, the DC component of the island was officially canceled, at least for the time being. This decision does not stop the physical construction of the caissons or the island itself, but it leaves the timeline for full operation uncertain. Originally, the island was expected to go online by 2030. Later projections suggested 2032. Now, without a firm plan for the DC equipment, no one can say for sure when the island will actually become fully functional. Designing with nature in mind. For all its industrial purpose, Princess Elisabeth Island also carries an ecological dimension. Recognizing the impact of building such a structure in the sea, the developers have worked with conservation groups on a nature-inclusive design. The caissons include ledges to attract black-legged kittiwakes, a seabird that has been declining in population. Artificial reefs will be created at the corners of the island, with rough surfaces to encourage shellfish to attach and grow. Flat oyster beds will be seeded to revive a species once common in the North Sea. Over time, these structures could support marine biodiversity while also protecting the island from erosion. The hope is that Princess Elisabeth Island can serve as both an energy hub and a new habitat, blending human engineering with natural resilience. The Summit of Ambition. The importance of the project was underscored at the North Sea Summit in Ostend in April 2023. There, leaders from Belgium, Luxembourg, the Netherlands, Denmark, Norway, Ireland, France, Germany, and the European Union gathered aboard the cable-laying vessel Connector. They toured a 3D model of the island with Chris Peters, CEO of Elia, Luc Vandenbulke, CEO of Demi, and Julie de Nul, CEO of Jan de Nul Group. The summit reaffirmed Europe's target of reaching 160 gigawatts of offshore capacity by 2030 and eventually building up to 300 gigawatts by 2050. For Belgium, Princess Elisabeth Island is more than a domestic project. It is a statement of intent that even a small country can shape the energy future of an entire continent. The road ahead. As construction continues, the challenges remain immense. The financial burden is high, the timeline is slipping, and the supply chain for DC equipment remains strained. Meanwhile, other countries face similar setbacks. Denmark, once a champion of offshore energy islands, has postponed its own plans until at least 2036 and even paused its wind financing strategy in early 2025. And yet, the vision persists. A network of offshore islands, cables, and turbines forming a web of renewable power across Europe is still on the table. If successful, it could reduce dependence on fossil fuels, shield consumers from volatile gas prices, and anchor Europe's energy independence for decades to come. For now, Princess Elisabeth Island is both a construction site and a symbol. Whether it becomes the beating heart of a new energy grid or a cautionary tale of ambition and cost remains to be seen. So what do you think? Will Princess Elisabeth Island become the spark that ignites Europe's renewable future? Let us know your thoughts in the comments below. And thank you for staying with us until the end of this deep dive into the world's first energy island.